All right, section 9.2, we are talking about adding and subtracting radicals. And we use this phrasing where we say, with adding and subtracting radicals, you can only add like radicals. We just mean radicals that are like each other. In other words, terms with the same value underneath the radical or the square root. So, for example, with 3 square roots of 2 plus 5 square roots of 2, for our answer, we're going to add the coefficients together. So we're going to take 3 plus 5, and then the square roots of 2, we're able to add the coefficients 3 and 5 because these terms both have the same radical, or they have like radicals. So that square root of 2 will not change. It will just stay at the end of our term. So to find our answer, sorry, I don't know why I wrote 3 times 5, it'd be 3 plus 5, because that's what we're doing, we're adding. So 3 plus 5 would get us 8, and then we still have the square root of 2. So that would be our final answer. If it helps, it's very similar to think of this as 3x plus 5x. In this case, we're basically going to treat the radical like a variable. So in this case, our variable or radical is the same, the square root of 2 and the square root of 2. So similar to how 3x plus 5x, I can add those to get 8x because they are like terms. In a very similar fashion, we can add terms with the same radical. So if we look over here, this is an example of terms that don't have like radicals. So I have 4 square roots of 3 minus 6 square roots of 5. This would be like taking 4x and trying to subtract 6y. These have 2 different variables, so I cannot combine them. So I would just leave my answer at that. I can't simplify. Same thing up here. 4 square roots of 3 minus 6 square roots of 5. There's no simplifying I can do. I cannot combine these numbers because they are not like radicals. So if it's helpful, which I think it is, to think of it in terms of variables, you can try and think of it that way. With that, let's go ahead and look at our first example. So we have example A, 2 square roots of 3 minus 5 square roots of 3. So first question is, are these like terms? Do these have like radicals? And the answer is yes, they both have a square root of 3. So because of that, I can combine my coefficients. So I have positive 2 minus 5. So I will be taking 2 minus 5. And then the square root of 3 stays unchanged. I do not, when I'm adding and subtracting radicals, I do not add or subtract the stuff underneath the square root. That has to stay the same. This would be like a label, so think of it like apples. If I have 2 apples minus 5 apples, how many apples am I going to have? I don't change my label from apples up here. This is apples, so I don't add them down here and get a different label. It has to stay the original label. So last step, we take 2 minus 5. That gets us negative 3. And the square root of 3 stays on the outside. So our final answer is negative 3 square roots of 3. Looking at problem B, now we have 3 terms. So when we look at these, we're going to ask, okay, are any of these like terms? Well, I have 8 square roots of 17 minus 3 square roots of 5. So those have different values underneath the square root. So those are not like terms. I can't combine them. Then I have 4 square roots of 17. So that one has the same value underneath the radical as this one. So I can combine these two as if they were like terms. So the way I do that is I will take their coefficients, 8 and 4. So it's positive 8 plus 4. And I will add those together, and my radical piece to that term will remain the same, square root of 17. And then I still have minus 3 square roots of 5. There's nothing I can combine that with, so that will stay by itself. So my final answer, 8 plus 4 gets me 12, and I have the square root of 17 with that, minus 3 square root of 5. Okay, go ahead and look at problems C and D. I want you to pause and try these ones on your own. Go. All right, so for my final answer for problem C, I got 6 square roots of 6. So we had a 5 plus a 1 square root of 6. Remember, if there's no coefficient, we assume there's a 1 there. And so 5 plus 1 gave me 6. Over here, I found like terms, and I highlighted them with the square roots of 3. Again, both of them don't have a coefficient in front, so we assume 1. So 1 plus 1 gets us 2 square roots of 3. And then I had a negative 4 and a negative 8. So when I combined those, I got negative 12 square roots of 7. Okay, so now we're going to talk about problems that don't look like they're like terms. That word appeared twice. That shouldn't be there. Watch out for problems that don't appear to be like terms. So in other words, if I look at this expression, so 2 square roots of 32 minus 9 square roots of 18, it does not look like those are like terms. The value underneath the square root is different. However, I can simplify the value underneath the square root for those. So for example, square root of 32, I could break this up into the square root of 16. I could break it up into the square root of 16 and the square root of 2, because 16 times 2 gets me 32. The square root of 16 is a perfect square. That simplifies to 4, because 4 times 4 is 16. So I can actually simplify my first term to 2 times 4 square roots of 2, which would be 8 square roots of 2. Similarly, with 9 square roots of 18, I can break down the square root of 18 into the square root of 9 and the square root of 2. Once again, I have a perfect square, so square root of 9 equals 3. So I can pull out a 3. And so 9 times 3 times the square root of 2. And that would simplify to 27 square roots of 2. And my operation in front of the 9 was a minus sign. So I bring that down. So now if I look, 8 square roots of 2 minus 27 square roots of 2. Now these do have like radicals. They're like terms. So I could combine these two. 8 minus 27, I believe that would get me negative 19 square roots of 2. So up here, all these previous examples, they're square roots. We could not simplify them. There were no perfect squares within them in their factorization, so we could not simplify. But we're now going to see some examples where they don't look like they are like radicals, but in fact, if we simplify them, we will see that some of them are. So we need to be careful. Let's look at some more examples here. So I have negative 3 square roots of 2 plus 2 square roots of 27 plus 2 square roots of 12. It does not appear that there are any like radicals, but we can do some simplifying. So the square root of 27 is the same thing as the square root of 9 times the square root of 3, if you look at the factors of 27. So that means I can pull out a 3 from the square root of 9. And then over here with 12, this is the square root of 4 times the square root of 3. And once again, the square root of 4, that equals 2. I cannot pull anything out of this square root, so that one will stay unchanged. So to simplify, I have negative 3 square roots of 2 plus 2 and then times 3, because I can pull out a 3 with the square root of 9. But then this square root of 3 will stay as a square root. Plus 2 times square root of 4 gets me another 2. And then I have the square root of 3. Now I'll simplify some more. So negative 3 square roots of 2 plus 6 square roots of 3 plus 4 square roots of 3. So I just simplified the multiplication. Now if we look for some like terms, I think we have them. I see 6 square roots of 3 and 4 square roots of 3. So if I combine those, that would get me 10 square roots of 3. So our final answer is negative 3 square roots of 2 plus 10 square roots of 3. So simplify the radicals and then determine if you have any like radicals. If you do, combine them. If you do not, then just leave your answer as it is. All right, I want you to think about this one for a minute. So we can have variables underneath square roots. If depending on what their exponent is, we may be able to pull a certain number of those variables outside of the radical. In this case, 14 square root of x plus 3y, or plus 3 square roots of y. these variables are not the same. So these are not like radicals. The square root of x doesn't equal the square root of y because we don't know what x and y equal. So because of that, there's no simplifying that we can do in this example. This is an example of, yeah, we don't have like radicals, so that is as simplified as that expression can get. Problem C. I already see I have two like radicals right away. Both of these terms have a square root of 2, so I will be able to combine those. I also see a radical that I can simplify. So let's go ahead and look at the square root of 12. I believe we already did that one above, but the square root of 12 is the square root of 4 times the square root of 3. And so if we have that as our factorization, the square root of 4, that is equivalent to 2. So I can pull a 2 out of the radical and multiply that by the coefficient. So to simplify, let's just bring down what we have. So negative 3 square roots of 2, minus 3 square roots of 2, minus 2, and then a times 2, because I can pull 2 out from here. And then I still have the square root of 3. Simplifying a little more, we have negative 3 square roots of 2, minus 3 square roots of 2, minus 4 square roots of 3. Simplifying this, we have like terms here and here. So negative 3 minus 3 is negative 6 square roots of 2. And then we still have minus 4 square roots of 3. All right, problem D, this is the last one. I want you to try this one on your own. Check and see if there are any radicals you can simplify, and then check for like terms.